Today, my interview partner is Jiang. He's Product Line Marketing Manager for the PMIC Group at Microchip. Alex, thank you very much for your time.
Thank you. Thank you for having me.
Today we will speak about the subject PMIC. I think for the starting, it would be a good idea that you give a short definition. What is a PMIC?
Sure. So a power management IC, which is known as PMIC in the industry, it has multiple functions. It integrates the DC to DC conversions, the LDO regulations, also known as low drop regulations. It also has power sequencing, voltage programmability, monitoring and control capability into one chip. So at the highest level, it is an integrated it is an integration of multiple power IC together, which can provide a lot of benefits for the potential customers, especially desirable to be used to power hardware in a complex system or applications. So that is what the PMIC is about.
What do you think? What are the unique features which are offered by a PMIC? The unique.
Yes. So PMIC is unique in the sense that if you compare that to a single buck converter or single boost converter, it provides a few extra features which are very useful for app system engineers. So for example, the first feature is PMIC takes care of power sequencing. So imagine you have a system which has an MCU or a microcontroller or NPU, a microprocessor, also a system around it will have DDR memories, will have sensors, a few other analog components. Then turning on and ramping up the voltage at a startup and shutdown at the right time is critical. So we need to make sure that certain rails come up before others and make sure that voltage stabilizes and give it certain delay before the next rail gets powered up. So it will prevent unstable conditions. It will also avoid inrush current for the upstream circuit, because if you're turning on everything at the same time, it causes a lot of inrush, which is create trouble for the upstream circuit that's powering this whole system. So that is feature number one. Feature number two is PMIC is providing a lot of voltage programmabilities. It is a very versatile chip. You can adjust the voltage in the PMIC in response to multiple power saving or performance enhancement modes, right? You can have a sleep mode, you can have active mode, you can also have a very ultra low power shutdown mode, depending on your system needs. And you can do it within one chip for multiple rails. So that is a great benefit and also very unique to PMIC. The third point is PMIC. You can program a lot of monitoring and control functionality, monitoring incoming and outgoing voltage and current and thermal limits during the operations. You want to alarm your system if some voltage power goes down so that it offers a lot of protection. The PMIC can also sending an interrupt signal to the microcontroller or microprocessor it is powered to signal that there might be some warning or some unexpected event happening in your system. So the design knows that everything is in shape, right? Yeah. So I think the last unique point is the PMIC has multiple operating mode, which I touched base a little bit. Basically, we use PMIC to power an intelligent system, which nowadays more and more a customer demands very low power consumption and it needs very low quiescent current. So in this case, we embed multiple operating system to help customer achieve that. So the microprocessor could be sleeping and our chip could be sleeping too to save more power.
Alex, some of the features you told us is you can achieve them also with discrete components. So what are from your point of view, what are the biggest advantages if somebody choose a PMIC over a discrete solution?
Yeah, that's a very good question. So as I said, PMICs is an integration of the discrete components. So we basically put everything into the silicon, but in a complex system, when the hardware designer needs a complex power solutions, using discrete components, the main disadvantage is first, it could be pricey because you are paying for multiple packagings, multiple testing time for those each discrete component. Also, discrete components are not highly integrated, so the PCB space is larger, mostly than the PMIC integration solution. And also, as the number of rails or voltage domains increase, it is getting more difficult to design a full system solution with discrete components because you need to add in more power sequencing chip. You need to put in more monitoring and supervisory chips, and this all adds up to the cost. So in this regards, PMIC is actually is a very advantage place.
A lot of advantages. Do you think there's at least some limits which you can't overcome with PMICs? Yes. Instead of if you use a discrete solution?
Yes. So PMIC are mainly made for, the history of PMIC is it started with personal electronics, like in the cell phones, in iPhone, you have a few PMIC, or in tablet, you have a few PMIC to power processor, to power the memories. And you can imagine PMIC mainly works to power efficient loads, like you cannot use a PMIC with integrated MOSFET to power very high current, heavy loading. So for example, you can power iPhone's microprocessor with a PMIC, but you cannot power, let's say, a server or data center processor with a PMIC because it just cannot handle that much current. So the sweet spot.
Is it just a question of time? So do you think in future the semiconductor industry will offer such kinds of products?
So right now, I think with new material like gallium nitride, wide bandgap materials, the internal power capability with PMIC is increasing. However, I can see that in the current status, the PMIC will still stay around personal electronics, phones, tablets. In servers, they have other type of architectures, right? They have multi-phase controller, which is has separate MOSFET outside for heat dissipation and other concerns. So in this regards, I think PMIC will assume more and more responsibilities inside industrial or communication applications, maybe not powering the main device, but power the peripherals around the PCB, like gating, for example, in the cars, you can use PMIC to power the safety MCU, or you can use cars to power you can use PMIC to power the infotainment system in the car. So we are seeing PMIC going from power personal electronics into automotive, and also I won't be surprised if PMIC also finds its way into industrial applications, right?
Okay. Edge computing, hot subject. So how are high-performance PMIC enabling edge computing for the future?
Yes. So if you look at edge computing, basically what it does is it aggregates data from the nodes and process them locally. And these kind of nodes are sometimes just powered by battery, and it needs very stringent requirements on the performance of PMIC. So the PMIC needs to be able to improve battery life. So it needs to be low quiescent current. It needs to be high efficiency. And also for most standard microprocessors, it needs something called dynamic voltage scaling. Basically, it adjusts so it basically tunes the output voltage of the PMIC based on the workloads inside the microprocessor. So when you have lower microprocessor loadings, you can lower down the PMIC voltage. And when you have more loadings on the MCU or on the processor, the PMIC can be sent to a command to up the rail voltage to allow for faster clocks inside the intelligent microprocessor or CPUs. And this is very hard to do with discrete components, as I mentioned, and it needs a lot of handshaking communication between the edge processor and the PMIC together to achieve what we want to do in edge computing.
Just one question. Does it mean that these PMICs are optimized for special MCU or MPU, or is it still a general purpose PMIC?
So PMIC, so in this market, I would say a high percentage of PMICs are tuned or optimized for certain application.
Okay.
Because it's a highly customizable application. Yeah.
Okay.
So
also in this case.
Yes.
Okay.
That's definitely.
Okay. Just one last question. There are not a lot, but there are some different suppliers of PMICs. Where do you see the unique selling points of Microchip?
Yes. So actually you had a very good question asking about edge computing, and then we touched base a little bit on customizable PMIC. So most likely when you sell a PMIC, the PMIC will be anchored towards a certain intelligent device. Microchip being one of the largest embedded solution companies in the world, it has portfolio of microprocessor, MCU microcontrollers, and even FPGA. It is very hard to find such a complete portfolio among, let's say, TI or Maximum or ADI, right? So because of this advantage, the PMIC group inside Microchip, we have unique insights on the exact requirement of powering these complicated embedded devices where traditional power and analog competitors don't have. So for example, Microchip FPGA products have unique requirements for their core voltage. For example, very low ripple or very high accuracy, among certain, across operation. So it also needs dynamic voltage scaling to save power. And another example is microprocessor system need unique power sequencing to avoid certain operating conditions that if you let your memory voltage come up before your core voltage or the overlap, you are in this unstable conditions. So the PMIC group inside Microchip, we can provide fully validated reference design to power these FPGA or microprocessors through internal application collaborations. Thus, we ensure that customers don't need to spend their precious time debugging hardware and just focus all the energy into developing a firmware and applications that matters to them. That is our biggest selling point.
Alex, thank you very much for your time.